All right, welcome everyone. It's 5:02 p.m. Eastern Time on December 4th, 2025, and this is the very first video in the KZA Maths Association series. I'm working with a student who's got a very challenging teacher for college algebra, and he has them have plot points and graph and solve pretty complex equations with no calculator. And I know that's challenging for a lot of students because you are basically raised to be reliant on the calculator, and a lot of times it's not even y'all's fault. It's just the way that schools are doing things to try and make sure that they can get the test scores they need. So when you have a teacher that's going totally calculator free, it can definitely be a challenge. And if you are already involved in Algebra 2 and you've heard the word logarithm before, you know logarithms can get a little confusing themselves because they're kind of going the opposite of exponential functions, and yeah, they've got their own complications. So let's dive in. I'm basically going to show you an organized process, like I showed my student, about how I would solve this problem if given to me on a final exam, etc. Because it's very important to be able to plan what points you're going to choose for your graph. So let's take a look at this logarithm problem. I'm going to share my screen with you guys. All right, so you see that the teacher is saying he wants her to graph the following logarithmic function, make sure to determine the domain, include any asymptotes, find and plot any y or x intercepts, and graph a total of at least 5 points. So, whenever you have a problem where you're going to graph something or have to find points, what I recommended to my student is to go to the top left-hand corner of your paper and make a chart where you plot x, y. And that way, all the work you're doing in the middle, the whole time you're keeping track of something very important, which is the points that you're choosing. So before I dive in and choose any points, let's figure out what our domain restrictions are. So domain restrictions are very important, and there are only really three that you need to remember. So domain restrictions is that the argument of a log, so we'll call that A, so the argument of a log always has to be greater than 0. It cannot be negative, so you cannot use the equal sign. And another thing you need to memorize is that whatever this number is becomes the vertical asymptote. So instead of being allowed to equal that number, it becomes an asymptote. And that is just something you want to memorize about what happens when you solve logarithms or when you try to graph them. Asymptote. And sorry, I don't always spell or write perfectly. So yes, you'll definitely get the unedited version of me in these videos. If you're familiar with me from my NBA video work and my passion videos, it's always one take. And I've definitely got autism and ADHD, so it's a fun ride, people, a fun ride. So just watch the video and you'll get to see the whole thought process, but you will also learn some math. So yes, logarithms. The argument always has to be greater than or equal to 0. Then whatever number this happens to be, once you solve that, which we're going to do in a moment, becomes a vertical asymptote. Now, the other restrictions I'll talk about in future videos. If you have a root with an even index, meaning a square root, a fourth root, a sixth root, that is not allowed to be negative. So you would set that element under the root greater than or equal to 0. And then finally, you know this from early algebra, probably even pre-algebra, you are not allowed to have a 0 in the denominator of a fraction. So if you are dealing with an expression that has a fraction with a variable, you're going to set that denominator equal to 0, solve for that variable. It is not allowed to equal to that number. Therefore, that becomes a vertical asymptote as well. So here we've just got the log to worry about. So let's go ahead and get started on that. So we set this 1/2 x minus 1 is greater than 0. Add 1 to both sides. Always remember that when you do an inequality, you would solve it just like a regular equation, but just without changing the sign, unless you multiply or divide by a negative. Here, we don't have to worry about that. X is 1. And then you can either think of it as dividing by 1/2 or multiplying by 2. So remember with fractions, you've got the whole keep, flip, change. So you've got 1, and you can even call this here. So students trying to struggle with fractions if you have a whole number interacting with something that's a fraction. So the way to line things up nicely, just turn it both into a fraction. So that's basically 1/1. times. So we're keeping the top. We're changing this to a multiplication sign instead of division. And then we're flipping this. So that's your keep, flip, change, the reciprocal. So you're going to do 2 over 1, and therefore your answer equals 2. So your x has to be greater than 2. So that is officially your domain, is x is greater than 2. And you just have to memorize that because it's a logarithm, the 2 itself, x equals 2, is actually going to be your vertical asymptote where you're going to draw your dotted line. Now, most teachers do want their answers in interval notation, as I know this young lady's teacher does. So if you're going x is greater than 2, see if I can erase this faster by hand. There we go. Okay. All right. So we're going to write x instead of x greater than 2. Let's just write domain is going to be 2 to infinity. So remember that in interval notation, you never want to use a bracket if it is not allowed to touch that number. And it can never touch infinity. That is impossible. Therefore, the infinity, as well as the 2, has a parenthesis instead of a bracket. It is not allowed to touch those numbers. And then we also know that on our graph, we're going to have a vertical asymptote. So I'll just write VA at x equals 2. So if you think about it, and you can kind of maybe keep your graph or like your sketch of your graph down here in mind. So you've got x equals 2. So if x has to be greater than 2, what that means is look at this. There's going to be no y-intercept. Because y-intercept, it would have to cross the y-axis. That can't happen. So since it's only here, you have to say, okay, y-intercept does not exist. And you could even write that. So this young woman's teacher does not give partial credit, but some teachers do. If your teacher does, you want to be very clear about writing things down. So just writing no y-intercept so that your teacher will know that you investigated that. So no y-intercept. And then we move on to x-intercepts. So x-intercepts, something I teach early and often to students is that your x-intercept is where your function crosses the axis. So say it's something like this. There's your x-intercept. And if it's a function that does multiple things, it can cross multiple times. So when you say x-intercepts, that's the same thing as solutions. It's the same thing as zeros. It's the same thing as roots. It all means the same thing. So that is something that you want to keep in mind as you go through Algebra 2. And how do you find your x-intercepts? You always just set y equal to 0. So let's do that. So remember that your function is really just y. So finding our x-intercepts here. So x-intercepts, I'll label that as we find it. You've got g of x, so you want 0 equals negative 2 log 3. And then if we plug in 0 for, or sorry, not plug in 0 for y. Sorry. That was me losing my train of thought again. Fun times. Okay. So we've got our x-intercept, and then let's go ahead and see if we can solve for x. And remember that if your teacher is not allowing you a calculator, it means there is some way to solve it with whole numbers. Your teacher does not expect you to become a calculator. It just means you have to be strategic about how you are laying out the problem. So we've got negative 2 equals negative 2 log 3 1/2 x minus 1. And remember, your goal is you need to separate this part so that you can solve. So we get rid of that negative 2 by dividing negative 2 on both sides. And therefore, we've got positive 1 equals log 3 and then 1/2 x minus 1. All right. So you might say, well, what the heck? How does that help me? It's not very helpful if you do not know your log properties. So let's talk about that and about how log function and an exponential function relate. So how I remember it is like so. Let's see, change this color. All right, so we're back to red. So this little 3 is the base of the log. Now the base is 10 if you don't see anything. Otherwise, it's that little number underneath. So I'm going to call that B. And this is going to be, I'm going to call this X. even though there's an x here. So that's going to be b, that's going to be x. And this, as I said in the beginning, I'm going to call this a. So a is the argument of your log. And so what you do is you say 3 to the 1 equals a, because so this is going to be b x a. So b to the x equals a. And that is just something that you absolutely have to memorize when it comes to logarithms, especially if your teacher is not allowing you a calculator in solving things. So it's always b to the x, which is whatever is by the equal sign, equals a. So essentially what a logarithm is, it's working backwards. It's asking you, okay, what number would make this possible? So if we've got 3 to the first, so 3 to something equals a. But anyway, see, this is why you guys are gonna love my one take videos. I think I'm like making it more confusing now. So okay, moving on. So I've showed you how it goes. So once you get to this point, you've isolated it. You have b to the a, which is 3 to the first equals a. You actually have an argument, which is 1/2 x minus 1. So we've got 3 plus 1 plus 1. And then 4 equals 1/2 x. And then you can kind of do that in your head, or you can do divide. You can divide by 1/2, which is the same as multiplying by 2. X equals 8. So the bottom line is yay, yay, yay. Who wants to say yay? Okay, I think we're going to turn this on just real quick, just to say yay for the fact that we found a point. Because just getting to that point was not easy. So yeah, let's celebrate that. So you've got the glowing ears now. So glow, we found a point. And when you find a point, you want to write it in your chart. That's where you want to work on staying organized. So we found x equals 0, and then we've got x equals 8. Okay. So that is very important to keep track of. And you want to follow your teacher's instructions very carefully. Notice he said graph a total of at least 5 points. So not only do we have a very important item now taken care of, which is the intercept, we've also got one of our 5 points. So just to recap what we've done so far, we now know our domain is x is greater than 2. Our vertical asymptote is going to be at x equals 2. There's no y-intercept, and our x-intercept is where y equals 0, and we've discovered that x is going to equal 8. So that's going to be an important point for plotting. And again, we find that by isolating this logarithmic portion of the function and knowing that the property of logs, that it's just base to the x power equals the argument. So yes, these problems require a lot of practice for a reason. All right, let's erase that. But as you can see, I'm leaving the domain vertical asymptote. So all the information that the teacher wants. And most importantly, I've got my chart of points in the corner. All right. So now is where it gets harder. Because usually when it's a standard polynomial, I tell my students, okay, well, first you want to find intercepts, so just plug in x equals 0. And then after that, just do like 1, 2, 3, whatever, like plug in easy stuff. But that does not really work here because we don't have a calculator. So we can't just plug any whole numbers in here unless we're like math geniuses and be able to solve it in your head. So the important thing here is to not get stuck on when you're finding points because you can't do the standard, I always tell my students do -1, -2, 0, 1, 2, and then get points from there and then get a few more points if you need. That does not work here. So then what we have to do is actually decide based on the logarithmic properties. And I will show you what I mean by that. And then also, let's see if I can get this to turn. I'm going to keep the lights on, but not flashing. So we're going to flash the headband again when this whole problem is done. All right. So, you remember from the last thing we did that we've got our log properties, and we used the weird reason we know that's 8 is because we had 3. So I didn't show you the solution to that yet. 3 equals, oh yeah, okay, I did how we solve that. So it's because we got this part by itself. And we ended up getting to say 3 to the first power equals that argument of the log. That's how we found it. So we already know 3 to the first power. So then what you have to do is basically execute and say, okay, that 3 to the 0 equals 1. So we go x equals 0. So because the base is 3, what you do next is you kind of make a chart of all of your 3, exponents. So, and what I mean by that, maybe I'll put that on the right side to make that a little smaller here. Okay. All right. So we've got, I don't want to do that in a T. Okay. So you just kind of write it out, and you don't have to write it down, but the more you write down, the more organized you stay, and then the more, you can avoid having problems. Okay, let's see. The more you can avoid mistakes. 3 squared equals 9. 3 to the 4th equals 81. And then I forgot 3 to the 3rd equals 27. So anyway, yeah, I wrote that a little sloppy. Let me write that one more time. You guys can always fast forward through the video if you want, because I want to make that clear. Okay. So again, the reason I'm using this strategy is because I need to find out how to get 4 other points. The teacher wants 4 other points graphed, and we can't just pick random numbers to plug in for x because we cannot solve a logarithm in our heads. So we have to use the base rule to our advantage. So we know that 3 to the 0 power equals 1, because anything 0 power equals 1. We know that 3 to the 1st equals 3. 3 squared equals 9. 3 to the 3rd equals 27. And then 3 to the 4th equals 81. Okay, so we are going to use those. And then what you want to do, I highly suggest if you are, trying to keep yourself organized on a test or quiz, is to make a chart. So you need to work backwards and basically find x's that work within these specific calculations. So this is what I mean. These are your answers for the powers of 3. Because the argument of a logarithm, it is the answer for what power do you take the 3 to. So we've already got 3 to the first power. So then we just go, okay, 1, take it to the first, third, 9, 27. Okay, so then we'll have to work backwards to find the x, and then the exponents for the powers of the log 3. So exponents. So here's where you're going to plug in the actual exponents. So the exponent you're plugging into here. So we've got log 3, 1/2, x minus 1, and then g of x. Okay, so the exponent here is going to be, so we have the answer is 1. The exponent is going to be 0. So 3 to the 0 power equals totally forgot what I was doing here. Okay, hold on 1 second. Let me get organized and then I'll come back to you. How do I stop the recording? Oh, here we go. There's the pause. I'm gonna pause this recording so you guys get to see me in real time, like figuring this out. Okay, let me get this chart more organized before I finish presenting this to you. Okay.